Hi, welcome to Mission Control Houston. Today we're talking with Chris Provencher, who is the project manager for the Spheres satellite project that has been on the space station for a while, a long and storied history, I guess. So, actually, Chris, if you could just start by maybe giving us a little bit of a history of the program.
Well, my robotics group at NASA Ames Research Center is investigating the use of robots to work in human exploration missions. So we're not looking to replace humans on their missions. We're looking to enhance their missions and provide more value to them. So specifically, we're looking at the use of robotic free flyers, so anything that can float in space. And we recognize that the Spheres platform is a great opportunity for us to do some free-flying robotic testing. So the Spheres is a free-flying satellite. It's got structure. It's got a propulsion system. It has some limited processing and can operate within a limited space on space station. So it doesn't have everything to become a robotic free flyer, but it is a great opportunity for us to do our testing.
Where'd the idea to use this on the space station come from?
Well, the Spheres predates my project. The Spheres is a payload facility that involves many different payload users. Whoever has a need to do some type of zero-G testing on a free-flying satellite can apply to do their testing with it. So that's run by the Spheres program. So I'm with the Smart Spheres project, so we are one of many users of that payload facility.
Okay, so smart spheres, that's the ones that use the smartphones. How did that come about? What's the point of that?
Right. So the Spheres, though it does have propulsion and some processing and navigation system, it doesn't do much other than fly around. And for it to be a robot, it needs to provide some useful tasks to the space station. So to do that, we need to communicate with it. We need some more processing. We need to be able to control it. Then it needs appropriate sensors for doing different types of tasks like cameras or other things. So everything I just described is what you'd find in a smartphone. So that was really a really low-cost approach for our project to upgrade the satellite from spheres to smart spheres without having to invest in a lot of development. So.
Okay, and y'all have had that up there for a while, right? But now it's time for an upgrade?
Yeah, so we did amass a smartphone in 2011, and we've been able to control that robot from the ground and have the ISS crew control it, and it's been very successful. But this new smartphone we have is actually quite impressive. So,
great, show and tell.
Yes, show and tell. So I did mention that the Spheres is constrained to a very limited operating environment on the space station. It's only like a 2 meter by 2 meter by 2 meter cube that it works in. This smartphone is called Project Tango. Google just announced this as a prototype release.
Project Tango?
Project Tango.
Okay.
So it's not available yet in stores, but it's available to some Android developers.
Okay.
What's really impressive about this is that it's got an IR projector. So it's similar to some games that can see your body moving. This phone has that as well. So it has an IR projector and then an IR camera that can see that projection. So basically, this phone can see in 3D.
Wow.
Also, it has a wide-angle lens and then a processor dedicated to visual odometry. So this camera can see things, edges, corners, just anything that's not really plain background. And then it tracks all of the features that it sees from frame to frame. And as the phone is moving, those features change position in each frame, and they can calculate how far it has moved. So with the 3D mapping and the visual odometry, this smartphone is capable of vision-based navigation.
So I'm sorry, what part is this smartphone here? Is it this or
right,
all of it?
So actually the white frame is what the regular smartphone would look like. So we've modified this to operate on ISS. We basically butterflied this phone open so that all the things that are typically on the back of your phone are on the same side as the touchscreen, so that they're all facing out and away from spheres.
Okay.
And then we built this bracket as well to mate it to spheres.
I see. Okay. And it seems like the main thing you're wanting to get out of this is the 3D camera. Is that right?
It's the navigation.
The navigation,
right,
okay.
Which uses the 3D camera.
And why is that special?
Well, if you want a robotic free flyer to do useful work on ISS, it needs to pretty much fly anywhere on the space station. And so to do that, it needs a very robust navigation system, and we think this might be it.
Okay, and I guess if I understand correctly, you've actually already tried this in zero gravity on a airplane flight here in Houston, and I think we actually have some video of that we can show. But how did that go? What did you do?
Right. So this phone was actually built to work on Earth.
Okay.
And it actually relies on a gravity vector. So we've had to do a lot of modifications to the software to remove the gravity from the equation. So we're doing some zero-G parabolic flight testing out at Ellington Field, and so far the tests are going real well. We still have yet to analyze the data.
And I guess what we're seeing here is the smartphone attached to one of the Spears satellites, right?
That's exactly what you're seeing. And as we hit zero-G, we release it in the cabin of the aircraft, and let it try to localize itself in zero-G. So,
okay. And you said it went well, huh?
well, we're collecting the data. We'll see how well it's working probably once we get back to Ames.
Okay. Well, once you had a chance to take a look at that, assuming it went well, what's the next step? When do you go to the space station?
The next step is space station, and we are supposed to launch on May 1st on Orbital 2. And then this summer we'll have 2 activities with the ISS crew to see how well it can navigate through the space station.
Okay. Well, we look forward to seeing that in space. And thanks so much for visiting us and telling us about this. It sounds like a great project.
Thank you.
Thank you.